this exercise, we'll be looking at a question which involves sets, some probability, and then generally number or numbers. So remember, we provide these exercises as a compilation in the form of a booklet. So you can contact us to get that booklet so that you can attempt to do the questions before looking at this video solutions. It will help you a lot if you do it in that way. If you take that approach, that is, try out the questions on your own to test yourselves, and then when you get stuck, then you can come and watch this video solutions. All right, let's move on with the question. So we have a universal set here which contains numbers 1 2 3 up to 14, and then we also get set f, and then this is the description of set f. We are told it is x such that x is a factor of 14, meaning set f is made up of elements in this universal set, but then only the elements which are factors of 14. Remember, factors of a number are numbers which can divide that particular number and then leave no remainder, or without leaving a remainder. And then set p, this is the description of set p. X such that x is a prime number less than 14, meaning the elements in set p are also in this universal set, but then there are only the prime numbers less than 14. So Roman figure 1 says write down the elements in set f. Remember, set f, it's numbers in the universal set, but only those ones which are factors of 14. So the factors of 14 in this case, that is numbers which can divide 14 without leaving a remainder, that is 1, 2, 7, and 14 itself. All right, let's move on to number Roman figure 2. Write down the elements in set P. So remember, set P, the description of set P says x says that x is a prime number less than 14. So these numbers x are the numbers in the universal set, but then only those ones which are prime numbers less than 14. Remember, a prime number, it's a number whose factors are only 1 and itself, or they are numbers which can be divided only by 1 and the number itself. So in this case, out of this universal set, the first prime number, or don't make the mistake of thinking 1 is a prime number. So in the list of prime numbers, the first starting prime number is 2, not 1. Because a prime number has only 2 factors, remember. So 1 has only 1 as a factor, so it's not 2 factors, it's only 1 factor. So meaning the first prime number should be 2, not 1. So that is 2, then 3, then 5, then 7, then 11, then 13. And then this will be all for Roman figure 3. All right, let's move on to Roman figure 3. Okay, the previous question was Roman figure 2. So in Roman figure 3, we are told to complete the Venn diagram in part A of this question. So what we can do, we can say that in this Venn diagram, there's an intersection of set F and set P, meaning there are elements out of the universal set which belong to both set F and set P. So let's go back to Roman figure 1 and Roman figure 2 in this part. So we can see that when looking at set F and also looking at the elements of set P, we can see that there is 2 in both sets, and then there's also 7 in both sets, meaning in the intersection here we have 2 and 7, and then in this area will be the rest of the other elements in set F, and then in this area here will be the rest of the elements in set P excluding 2 and 7, meaning for set F we'll have 1 and 14 here, and then for set P in this area or in this region we'll get 3, 5, 11 and 13. And then every other element which was in the universal set will come outside here. So that would be 4, 6, 8, 9, 10 and 12, because these are the elements which are neither in set F or in set P. So this is how you should complete this this Venn diagram. All right, let's move on to the next part of this question. So number B, we are told write down n bracket F intersect P. What this means, this n stands for number of elements in F intersect P. That is how many elements belong to set F and set P. So if we go back to the Venn diagram that we had just completed, we can see that in the intersection of set F and set P, we only have 2 elements, that is 2 and 7. So our answer here for number B will be 2. And then for number C, we are told that a number is chosen at random from the universal set. That is, only one number is chosen at random from the universal set. And then write down the probability that the number is in the set F union P. Remember, the union of a set means all of the elements in set F together with all the elements in set P. So since we want to find the probability, we want to find how many elements are in F union P out of the total number of elements that we have in the universal set. So let's go back to the Venn diagram, or the question where it starts. So you can see that the universal set is numbers 1 to 14, which is actually a total of 14 numbers. But then in the Venn diagram, we can use it to find actually the total number of elements which belong to F together with the elements which belong to P. So this is 1, 2, 3, 4, 5, 6, 7 and 8, meaning the number of elements in F union P, it's 8 elements in total. That is the elements in set P together with the elements in set F. So to answer this question about probability, write down the probability that the number is in the set F union P. So the number of elements in F union P, it's 8 elements. So the probability of getting an element which is in this set, which is in F union P, out of the total number of elements in the universal set will be 8 out of 14. So you can leave this fraction as it is, since we were not told to write the answer in its simplest terms. So you can just leave it as 8 over 14. It's fine. All right, moving on to number B. Write 195 as a product of its prime factors. Now we want to write 195 as a product of numbers, but then those numbers should be only prime numbers, meaning it should be prime numbers which can divide 195. So you can do that using a factor tree like this. So this is what you do. The first, let's list a few prime numbers here. It's 2, 3, 5, 7, 11 and so on. And then 2 would not divide 195 and it would leave a remainder. So we try 3. So 3 can divide 195 and then leave no remainder. So that's what you do. Write the 3 here, and then you say 195 divided by 3, that should be 65. And then you break down the 65 further using any of these prime numbers which you can be able to use here. So you go again, 2 cannot divide 65 and leave and not leave a remainder, so it would leave a remainder, so we'll not use it, so we'll use 3 instead. So we'll say okay, 3 would not work, sorry, it would not work. Let's try a different one. 5, yes, 5 can go into 65 and not leave a remainder. So 65 divided by 5, that gives 13. So once you get to a number that you cannot break down any further using these prime numbers, then that's where you stop. Meaning in the product that you write down, you say 3 by 5 by 13. So notice that the number that you end with should be a prime number. So you get 3 by 5 by 13 as your answer, and then that will be all.